Histograms are similar to stem and leaf plots in that they give us a picture of how the data is spread out. However, stem and leaf plots are of limited use if the numbers in the data set don't have a nice variety of first digits. For example, if we asked a whole bunch of people how many siblings they have, there just aren't that many people who have 10 or more siblings. So almost all of our data is going to have a first digit of 0, and then all we'd have is just this long list of numbers with a single stem, and that wouldn't be terribly useful. Histograms help us get around that and provide a nice other way to visualize data. So let's define what histograms are for starters. A histogram is a bar graph where for one thing, the bars touch. The width of each bar represents a range of quantitative, so that's just numerical, values, and these are called a class. So you've seen histograms before, most likely. It's something that looks kind of like this. So like this might be 0, 5, 10, 15, and then the height, which I'm going to write in just a second, 1, 2, 3, 4, is how many values there are between 0 and 5, between 5 and 10, between 10 and 15, and so on. So that's what a histogram looks like in general. And as I just mentioned, the height of the bar is the frequency, which is how often something occurs, or the relative frequency, the percent or proportion of time that something occurs. So again, frequency is the number of times particular values occur, and relative frequency is the proportion of times. Typically, the number of classes, or the number of bars, is going to be between 5 and 15. And the reason for that is if we imagine a data set like this from 0 to 15, if we just had one interval, one class, one bar, then we would say, okay, this is how many values there are, and it wouldn't really give us a very good sense of what the data was clustered, whether it was clustered on a particular interval, whether there were any outliers that were way off to the side, that kind of thing. So this is too few. Whereas if we said, okay, every single value is going to get its own bar, then we might have something that looked like that, and that's not really very useful either. It's basically just listing the numbers in order. So let's do an example. Make a histogram with 5 classes to summarize the number of siblings recorded below. So let's say we ask a bunch of people and someone has 0 siblings, another person has 1, somebody else has 3, someone else has 5, and so on. So these are the numbers that we got from asking people how many siblings they have. That's a 1 and a 1, not an 11. Make that clearer. Okay. So the first thing that we're going to do is order the data and identify the largest and smallest values. So I'm going to write the steps that we're using over on the side here, and then do the example over here. So first of all, we can also just look and eyeball this. It looks like it's going to be 0 and 9, but it will be useful to have the data in order. So again, we go up. Oops. There we go. Clear. 0, 1, 3, 5, 3, 3, 3, 2, 2, 1, 1, 0, 3, 8, 1, 1, 0, 2, 2, 9. Okay, there's our list of values. And as we've done before, stat sort ascending L1. Okay, so as we saw before, we've got 3 zeros, several 1s, 2s, 3s, and 9 is our highest value. So smallest now what we're going to do is find the class width, and what this is it's just how wide each bar is if there are 5 bars or 5 classes. You're going to be given in the problem how many classes to use. If you're doing something on your own, you would probably play around with this a little bit just to try to find a number of classes. If you have a lot of data that's really clustered close together, you're going to use fewer classes. If you have data that's really far apart, you're going to have more. But just to see what sort of gives you a nice distribution that isn't too much like this, but also isn't too much like this. For purposes of all getting the same answer, I'm just going to give you how many classes there are. And so the way that you do that is we say, okay, we've got numbers from 0 to 9. I want to divide that range into 5 pieces. So what we're going to do is find the class width, which is how wide each bar is. If there are 5 bars, we're going to do that by dividing the range, and we'll learn about range in a bit, but it's just largest minus smallest. Values by the number of classes. In this case, 5. So what we're going to do here, largest minus smallest over number of classes, 9 minus 0 divided by 5. This equals 1.8. Here's the thing though. We are going to always round up. So this 1.8 is going to become 2. There we go. If this had been 1.2, 1.00001, doesn't matter, we're always going to round up just to make sure that we capture all of our data. Okay, next thing that's going to happen label the x-axis starting at the smallest value and counting by the class width. And after, not on the largest value. So in this case, our smallest value was 0. So we're going to start at 0. We're going to count by 2's. Two, 4, 6, 8, 9 is our largest value, so we have to go past 9 to 10. Our next step is going to be count how many values fall within each interval. Draw a bar that high and label the frequency. One thing that's very, 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 very important, numbers on the border between two classes. And remember, those classes are just these little intervals. Are counted in the one on the right. This does vary a bit depending on what statistics class you're working with. There are some other ways of doing it, but we're just going to use one of the simpler conventions here. If we have a number like 2, 2 goes in this interval here, not this interval here. So let's see what that looks like. So we had 0, 2, 4, 6, 8, 10. And so this is number of siblings. And this is going to be frequency. So frequency is just how often something occurs. And make sure to label and so if we go back to the calculator, we're just going to count how many numbers are between 0 and 2. We're not going to include 2. 2 is going to go to the right. So we're basically just going to count how many zeros and ones we have. So I go 1, 2, 3, 4, 5, 6, 7, 8, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. And there's our bar, and I'm just going to label the actual frequency on there. Okay, so now we're going to go how many 2's and 3's we have. Don't include 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the next one's a 5, so we have 9 2's and 3's. And between 4 and, so how many 4's and 5's do we have? Looks like we've just got 1 5. numbers between 6 and 8. Remember, we're not including 8, so there are 0. And we have an 8 and a 9. So we have 2 in between 8 and 9. And voila! There is our frequency histogram. So this looks like it takes a long time just because I was writing out all the steps here. It actually really doesn't. Let's do a second example. You can see how quickly it goes. Okay, we're going to create a histogram of 7 classes summarizing the length of time on hold in minutes. And the data set that we have for that is as follows. We've got 5 minutes, 5 minutes, 6, 7, 4, 8, 7, 6, 5, 5, 6, 7, 6, 6, 5, 8, 9, 9, 10, 7, 8, 11, that is a 7 and an 8, not 78, 2, 4, 6, 12, 13, 6, 3, 7, 9, 10, 17, and 14. Okay, so the first thing we're going to do is we're going to find that class width again. So if we just look through here, 2 is our smallest value, 17 is our largest. We're going to have to go and sort the data at some point anyway, so we might as well do that now just to double check that those are correct. So I'm going to put them all in. Okay, got 34 values in there. I do my usual stat, sort, L1, and go back. Okay, 2 is the smallest, 17 is the largest. So the class width is 17 minus 2 divided by 7. When I do that, I get 2.1. Remember, we're always going to round up even if this is less than 5. So that's the class width. So when I do my little histogram here, I'm going to start at 2, and I'm going to make this little symbol right here which just says that I'm not starting at 0. So I'm going to start at 2, I'm going to count by 3s. So 2 plus 3 is 5, 8, 11, 14, 17. And remember, we need to go past the highest number, so add another 3, get up to 20. Now what I'm going to do is I'm just going to count how many numbers there are between 2 and 5, not including 5. So 1, 2, 3, 4. And it's good practice to label it right away. So this is time in minutes. This is frequency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 11, 12, 13, 14, 15. So let's see, I just said that there were 4 between 2 and 5. So 1, 2, 3, 4. Now let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 between 5 and 8, not including 8, so 15, I'll make this a little higher, 16, 17. Ooh. Okay, and now between 8 and 11, there's 1, 2, 3, 4, 5, 6, 7, 8, 8, because 11 doesn't count. Between 11 and 14, 1, 2, 3, 14 doesn't count. Between 14 and 17, there's just 1, 14. And between 17 and 20, there's another 1. So, there's our little frequency histogram. Doesn't take too long. The one final piece that we're going to look at today is that there's also something called a relative frequency histogram. And that's really not that much more complicated than what we just did. I'll just keep this for reference as we do that next piece. Should be an A. So remember, relative frequency just counts the proportion or percent of values in an interval instead of the number of values in that interval. And the point of that is just that it lets us compare data sets with different numbers of values. To calculate a relative frequency histogram, do the same thing you did. Do the same thing you did for a frequency histogram, but divide all y values, remember these are the frequencies, by the number of values. So if we take this, I'm just going to rewrite, so here's our example. Create a relative frequency histogram for the previous example. So we're going to take this example that we just had. I'm just going to recopy it right here. And let's see how many values we have. We can count them up. But also notice right here, this is saying L1 number 34. So if you just go to the last value, you can just see right there how many values there are. Or if you wanted to you can just go back and count 1, 2, 3, 4, up to 34. So we're going to divide each frequency by 34, which is the number of values. So, other than that, it's going to look pretty much the same. So this is going to be a relative frequency histogram. But now this one is 4 divided by 34. Go ahead and round to 2 places after the decimal. So I'm going to label this 0.12. This one is 17 divided by 34. Or 0.5. This one was 8 divided by 34. And it rounds up to 0.24. Three divided by 34, 0.09. And then 1 divided by 34, 0.03. Now that I've done that, it is important to have something for the y-axis here. But we can just do a scale that makes sense. So we can just count by tenths here. For example, here's 0.1. This is going to be about 0.2, 0.3, 0.4. And that is a relative frequency histogram. We are all done.